everyone and welcome. Today we are going to talk about the concept of scalability in Azure. Okay, first we're going to see agenda. Okay, first we're going to see what is scaling and its types and what is auto scaling and how it works. Okay, so first of all, what is a scaling? In Azure, a scaling refers to the ability to dynamically adjust the amount of computational storage or a network resource allocated to the application or service to meet changing demand, optimization performance, ensure availability, and manage cost efficiently. Okay, so next one is its type. There are two primary types of scaling. We will discuss vertical scaling and horizontal scaling. So let's start with a vertical scaling. This types of scaling involves increasing or decreasing the capacity of single resource. Think of it upgrading or downgrading a single server with a more or less CPU memory or disk. You can change the size of an existing instance. For example, moving an Azure VM from a standard A2 size to a more powerful of standard A4 size. Okay. So next we have horizontal scaling. This involves adding or removing instance of a resource. Imagine adding more identical servers to handle increased traffic or removing them when demands drop. For instance, you could increase the number of virtual machines, a web apps instance, or other service instance that are running in your application. Okay, so now let's talk about auto scale. Okay, Azure, auto scale is feature within a Microsoft Azure a cloud platform that automatically adjusts the number of resources, primarily in instance, okay, allocated to your application and services are based on predefined rules and performance metrics or schedule. Okay, so the auto scale actually work how it is work. It depends on their predefined rules and their metrics and their schedule. Okay, so next, how Azure's autoscale works. So how does Azure autoscale works? It operates based on several key components. First one is the metric based rule, second one is schedule based rules, and third one is instance limits, and fourth one is cooldown periods, and final one is predictive autoscale. Okay, so first one is a metric based rule. Metric based rules are central to autoscale. These rules use performance metrics to decide when to scale. For example, a scale out rule might state if average CPU usage across instance is above 70% for 5 minutes, add one instance. Conversely, a scale-in rule could be if average CPU usage across instance is below 30% for 10 minutes, remove one instance. Okay, so next one is a schedule-based rule and instance limit. So okay, the first one is suitable for schedule-based rule, and second one is definition of instance limit. Okay, so auto scale is also for a schedule-based rules. You can define scaling actions based on the schedule. For example, ensuring at least 5 instances are running every weekday from a 9 a.m. to 5 p.m. or a scaling down to 2 instances on weekends. Additionally, you always set a minimum and maximum number of instances for your resources. This ensures that autoscale operates within your desired boundaries and helps to control the cost. Okay. So to next one is a cooldown period and predictive autoscale. So what is cooldown period? So to prevent flapping it means rapid scaling up and down. Okay, this is called flapping. Autoscale applies cool down periods between the scaling events. It's dynamically changing, scaling up and down. here we use auto scale method. Okay, so this one is a predictive auto scale for virtual machine scale sets with cyclical workload patterns. Azure can use a machine learning to forecast a CPU workload based on historical data, allowing it to scale out proactively to meet a predicted demand. Okay, so this is about the what is scalability, and now we complete the session right now. So thank you everyone. Thank you.